Good afternoon, everyone. So just in the next 10 or 15 minutes, I'll talk about the AMPC sustainability program from an environmental perspective, what's involved in that. And then part of the environmental program that covers waste valorisation and circular economy, I'll talk about projects in that work and how we build those projects, how we identify what we should be doing in that area. First of all, AMPC acknowledges Aboriginal and Torres Strait Islander peoples as the first Australians with unique and continuing connections to land, sea and nature. We pay our respects to elders past and present across all the lands in which we operate. So AMPC has three strategic pillars, and these are important for me to describe so you can understand the things that impact how we design our projects. So first of all, the first pillar, industry excellence, is about being trusted and transparent for our customers, for our members and any other stakeholders that are interested in red meat. It's basically knowing where we've come from and where we have to go to as far as the environmental sustainability aspect is concerned. And also being responsive to community expectations and practicing continual improvement in that respect. So it's more about knowing, measuring and verifying is the big thing with industry excellence. The next pillar is innovation and technology leadership. This is more action-based. So once we know where we're at and where we need to go to, we're then developing actions through R&D that create efficiencies, productivity, give members a competitive edge and enable adoption of advanced technologies. To do that, we need to collaborate with global and local innovators, and we do a lot of that as part of our R&D. The final pillar is growth and global competitiveness. So as you can see at the top, once we know where we are and where we've got to go and we've got an action, once we complete that action, then the R&D will value or measure and confirm the market opportunities, the improved market access, the improved carcass value, the improved profitability. And that's essentially the strategic pillars. So in the sustainability program, as far as the environment is concerned, there's a hierarchy as far as the work is concerned. So communities and decarbonisation is its own separate piece of work, as you can see down the bottom of that triangle. Reporting is a big part of creating transparency. Once we have transparency, we can build trust. Once we build trust, we can then develop co-investments in R&D. Clean energy transition is similar. So down the bottom of that pyramid, measurement and verification and benchmarking is the first step. Once we've done that, we can create efficiencies leading on to renewables, and then at the top is power purchase agreements, again the investment side of things. For responsible water management, very similar. So down the bottom, measurement and verification and benchmarking, creating efficiencies in water use, and then leading on to advanced recycling. With the waste valorisation and circular economy focus area, it's again measurement and verification, finding out what wastes are occurring, where they are going and what their characteristics are. And then practicing landfill diversion, getting some recycling happening, and circular economy as far as the investment is concerned. As far as performance on the environmental KPIs, AMPC has been running the environmental performance review since 1998. We do it every 2 years, and this describes and measures and illustrates the environmental performance for the sector. So again, coming back to, we've got to know where we are, where we've come from and where we're going to. This is what the environmental performance review does. And the performance has been pretty good. So for example, with water intake intensity, we're at, in 2024, for the environmental performance review, it showed a record low in terms of water intensity at 7.3 kilolitres per tonne of hot standard carcass weight. That's down 16% since 2010. Water recycling is up which is what you want. So it's at a record high now across the sector. 16% of water consumed is recycled water. And water recycling has increased 45% since 2020. Water discharge intensity, again, this is the water that's going to irrigation, sewer and waterways. It's at a record low, so that's 6.5 kilolitres per tonne of hot standard carcass weight. In addition to that, the nutrient level discharge intensity is at a record low. It's dropped 70% since 2020. So that's helping reduce nitrogen and phosphorus in the environment close to those facilities. Across the page, we're looking at energy intensity. Again, 2024 was at a record low, 2,897 megajoules per tonne of hot standard carcass weight. That's down 30% since 2010. On-site coal usage, this has been really encouraging. It's falling rapidly. So it's down 27% since 2022, just a few short years. And these are good things, but I might say that we also find things that are not so good. We like to find those as well, so we know what we've got to do, still got to do work on. So solar PV adoption sounds great when you say it's gone up 400% since 2020, but it still only represents 3% of total electricity consumption in the sector, so we know we have to do more work on that. Then we come to greenhouse emissions intensity. Again, 2024 was at a record low, 330 kilograms of CO2e per tonne of hot standard carcass weight. That's down 17% since 2020. And as far as gross sectoral emissions is concerned, we're currently aligned with CN50, and its gross sectoral emissions have come down 25% since 2005. I was talking about good performance, and I was talking about not so good performance, and knowing where we're at and what we've got to do. Solid waste to landfill intensity is one of those things that we've got to do more work on, because we know where we're at, and where we're at is we don't think is good enough. So at the moment, 2024, we're at 21.5 kilograms per tonne of hot standard carcass weight solid waste to landfill intensity. That's up 87%. This is across red meat, by the way. This is the whole of red meat, including sheep and beef. So the beef and the sheep frameworks do separate out their independent results, but we prefer to look at this today just across the whole. So we know we need to act on this because it's moving in the wrong direction. There is a reason for that, and since 2020 there's been significant PPE, construction and demolition waste. Materials going to landfill has increased, and that's been a result of, with PPE, during COVID, there was a lot of that coming in to waste to landfill, and that hasn't stopped. A lot of plants have now upped their PPE adoption to much higher levels than what they had before, and that, as you'd expect, with increasing throughput, there's been need for plants to put on new slaughter floors, so construction and demolition waste has been increasing during that time. If we look at the solid waste to landfill, what is it? A lot of people say, oh, you know, so much of it is from the animal. That's not true. Most of the solid waste to landfill is inorganic waste, so it's not from the animal. In fact, 98% of the whole animal is utilised in some way, either for food, clothing, even for heart valves. So if I go back to the inorganic waste, which is the majority of the waste to landfill at 64%, that's even if we look at that and we try to work out what is that organic waste made up of, it's made up of hundreds of different types of inorganic waste. For example, facility level plastic is less than 13% of that component. So if we're thinking, oh, that's all plastic, no, it's not. Plastic is a small portion of that inorganic waste. So what's happening is processors are engaging with local recycling where it's available. They can't recycle this stuff themselves because it's so many different types of products. We need to go to regional or local recycling establishments to get rid of this stuff. If they're not available, it goes to landfill. There's no other option. If we look at organic waste, that is something we can do something about, and we are helping members with R&D to work on that. Organic waste is 36% of the total solid waste to landfill. Most of that is made up of paunch and non-commercial value hides and skins. Unfortunately, the bar for what's considered non-commercial value for hides and skins is now very low, and hence hides and skins don't have anywhere to go. That's an economic reality. Maybe there's some things, some R&D that can help change that, but that's going to take time. So the work we're doing around organic waste, we're trying to increase the value of non-commercial value hides and skins for their alternate use. So for example, with paunch as a feedstock for bioenergy, or with rendering hides and skins, which is very difficult to do because they're so tough. So we need to come up with ways in our R&D to make them softer, more malleable, separate the hair more easily. So pre-treatments are needed before they go to render. So just recapping on that, on the program and some of those projects with waste valorisation and the circular economy, particularly for inorganics. We did a project not so long ago with Southern Cross University, covered the used packaging material framework regulations, what support is available, what plastic supplier progress has been made. We looked at on-site plastic use, realised there were over 40 different type of plastic products on most sites, and remember there's 140 of them across Australia. And we had multiple processors provide information. There's a whole list of the different types of plastic, and we estimated 4,500 tonnes per year of unused packaging material in the form of plastics that goes to landfill. It goes via a waste collector. We're assuming it goes to landfill because we don't at the moment collect information from rubbish collectors as to what they're doing with it. But we assume that it is going to landfill because of the diversity and complexity of trying to recycle those different plastics. It's a tough job. It needs a lot of money and needs to be regionalised, and those forms of infrastructure just don't exist in the scale that's needed. So recycling of plastics in a plant is not feasible. It needs to be done at regional level, and that's where we're doing our future work, is working with local councils, other members in the supply chain over a regional area to see how these investments are going to take place. So if we go then to the organics, waste valorisation and circular economy, the first organic in the processing stream is the non-commercial value hides and skins. So previously, some of those hides and skins were considered to have commercial value, mainly because they're so durable. I guess you'd call them sustainable actually, hides and skins. But now they're considered not sustainable, and the commercial value has reduced. So the alternate value might be from tallow and proteins such as collagen with further processing. At the moment that processing is conducted overseas, it's not happening in Australia. So there's work we'll be doing around, as I mentioned before, looking at ways to make hides and skins more malleable, easier to take off the hair and the wool so that we can put them through rendering to extract the tallow and the proteins from that on-site process. That's a project that's just kicked off. Next, in the primary wastewater stream, at the primary end again, is using, this is a project which has used natural coagulants for wastewater treatment, get away from chemicals so that your downstream process isn't creating a carbon footprint or a chemical footprint that's not good for the environment. This has been a successful project. We've tested a tannin-based coagulant on a couple of sites, realised it's got an 18-month payback in terms of its cost of adoption, and it is helping to reduce downstream impacts as far as chemicals and carbon footprint is concerned. In the secondary wastewater treatment area, as far as the organics is concerned, another project we're doing with Race for 2030 is around anaerobic co-digestion That's a process whereby, you know, the standard procedure at the moment is co-digestion of organics that are on plant that are naturally high in protein and high in lipids. In order to get a more productive co-digestion process, there needs to be more carbohydrates introduced to that anaerobic digestion process. Those carbohydrates usually come from off-site locations that are convenient, hopefully, to the processor. So this project has taken a total of 54 organic waste streams, both on-plant and off-plant, conducted 219 biomethane potential tests and 7,000 hours of pilot tests to find what is the ideal lipid protein carbohydrate ratio and what productivity uplift can we get in biogas. Hopefully, well, through the biomethane potential test, it's shown a multiple uplift in biogas yield. We just now have to confirm that through the pilot tests. So that's ongoing work. Again, at the secondary wastewater treatment process, talking about pre-treating suitable solid waste for improved anaerobic digestion. So in a case where there's existing infrastructure, such as covered anaerobic lagoons, and we've got paunch, we've got sludge, what do we do with it? We can't use it in a cal at the moment because it doesn't break down very well in a cal. So this project is looking at an alkaline pre-treatment that will help break up the paunch and the sludge, particularly the digestible parts of paunch and sludge, so that the biogas productivity can be improved. That's taking place at the moment, or about to start that project. When we look at the tertiary wastewater treatment process, this is at the end of the line, right? So this is before it gets discharged to the environment or to trade waste or whatever the story is. The last opportunity there is to take those bioresources that have been processed through that wastewater treatment and then see if we can make a soil conditioner or a fertiliser. There's ongoing work in that area as well. So I think what this is all saying is that processors are serious about their continuous improvement in sustainability, and the evidence says they're making good headway. Thank you.